Hello everybody, again to the second video of the website learncpp.com, and we continue. In the last episode we went from 0.1 to 0.4 and now we continue at 0.5, introduction to the compiler, linker and libraries. And I quickly want to say this website is made by Alex and he is also sponsoring this website. He pays for it, and this website is all ad sponsored. And if you want to use learncpp.com, just put on the ads. As you can see, I don't have ads. That's because I'm making the video and post on YouTube, and I don't want to get any issues with the policies, and that's the reason for me. But if I use it for myself, I try to disable my ad blocker and support Alex with it. And now let's start with our 0.5 introduction to the compiler, linker and libraries. Continuing our discussion of this diagram from the previous lesson. And here we have all the steps. Step 1, define the problem to solve, design a solution, write a program that implements the solution. These 3 steps we did in the last video of it, and now we go to the compiling the program, linking the object files and test the program and the debugging. And yeah, step 4, compiling your source code. In order to compile C++ source code files, we use a C++ compiler. The C++ compiler sequentially goes through each source code CPP file in your program and does 2 important tasks. First, it checks your code to make sure it follows the rules of the C++ language. If it does not, the compiler will give you an error and the corresponding line number to help pinpoint what needs fixing. The compilation process will also be aborted until the error is fixed. And now I quickly want to show if I have started the recording. Yes, I did. And second, it translates your C++ source code into a machine language file, called an object file. Object files are typically named name-o or name object, where names is the same name as the CPP file it was produced from. If your program had 3 CPP files, the compiler would generate 3 object files. We have a source file called calculator CPP, so the compiler makes an object file calculator O. And then fraction CPP, then we have a fraction.o file, and math CPP, and we have a math.o file. And for everyone, yes, he makes an own object file. And CPP compilers are available for many different operating systems. We will discuss installing a compiler shortly, so there is no need to do so now. Step 5. Linking object files and libraries. After the compiler creates one or more object files, then another program called the linker kicks in. The job of the linker is threefold. First, to take all the object files generated by the compiler and combine them into a single executable program. For example, the calculator, fraction and math file are put into the linker, and then we have our standard library for all the commands that we are using in our code, and other libraries if you have any other libraries. And then we have an executable file that is called the exe file. And then second, in addition to being able to link object files, the linker also is capable of linking library files. A library file is a collection of precompiled code that has been packed up for reuse in other programs. C++ comes with an extensive library called the C++ standard library. You know it when you program under the std, usually shorted to standard library. That provides a set of useful capabilities for use in your programs. One of the most commonly used parts of the C++ standard library is the IOStream library, which contains functionality for printing text on a monitor and getting keyboard input from a user. Almost every C++ program written utilizes the standard library in some form, so it's very common for the standard library to get linked into your program. Most linkers will automatically link in the standard library as soon as you use any part of it. So this generally isn't something you need to worry about. You can also optionally link in other libraries. For example, if you were going to write a program that played sound, you probably would not want to write your own code to read in the sound files from disks. Check to ensure they were valid, or figure out how to route the sound data to the operating system or hardware to play through the speaker. That would be a lot of work. Instead, you probably download a library that already knew how to do those things and use that. We will talk about how to link in libraries and create your own in the appendix. And if you want to know where the appendix is, if you click on the home, again, there are at the very bottom here, as you can see, we have here at chapter A1, B, A, B, C, and the chapter 21 and 22 have an appendix A, B, C, and D. And you can see that here. And now back to the program, to step 5 again. And then the third, the linker makes sure all cross-files dependencies are resolved properly. For example, if you define something in one CPP file and then use it in another CPP file, the linker connects the two together. If the linker is unable to connect a reference to something with its definition, you will get a linker error, and the linking process will abort. Once the linker is finished linking all the object files and libraries, assuming all goes well, you will have an executable file that you can then run. Because there are multiple steps involved, the term building is often used to refer to the full process of converting source code files into an executable that can be run. A specific executable produced as the result of building is sometimes called a build. For advanced readers, we also include that. For complex projects, build optimization such as make or build2 are often used to help automate the process of building programs and running automated tests, while such tools are powerful and flexible because they are not part of the C++ core language, nor do you need to use them to proceed. We'll not discuss them as a part of this tutorial. Yes, they basically do, like it says, the linking, and if that you don't have to do them manually. There are programs for it that you can put in your files, say which system you use, which one you want to link in, and then it connects all together. And yeah, they're very quick and a very comfortable step to do. And now we are coming to step 6 and 7, testing and debugging. This is the fun part. Hopefully, you are able to run your executable and see whatever it produces out of you were expecting. If your program runs but doesn't work correctly, then it's time for some debugging to figure out what's wrong. We will discuss how to test your programs and how to debug them in more detail soon. Integrated Development Environment, IDE. Note that steps 3, 4, 5 and 7 all involve software: editor, compiler, linker, debugger. While you can use separate programs for each of these activities, a software package known as an Integrated Development Environment IDE bundles and integrates all of these features together. We will discuss IDEs and install one in the next section. And let's go there. Section 0.6: Installing an Integrated Development Environment called IDE. An Integrated Development Environment IDE is a piece of software designed to make it easy to develop, build, and debug your programs. A typical modern IDE will include some way to easily load a save your code files, a code editor that has programming-friendly features such as line numbering, syntax highlighting, integrated help, name completion, and automatic source code formatting. And a basic build system that will allow you to compile and link your program into an executable and then run it. An integrated debugger to make it easier to find and fix software defects, and some way to install plugins so you can modify the IDE or add capabilities such as version control. Some C++ IDEs will install and configure a C++ compiler and linker for you. Others will allow you to plug in a compiler and linker of your choice, installed separately. And while you could do all of these things separately, it's much easier to just install an IDE and be able to do all of these things from a single interface. So let's install one. And now choosing the IDE. The obvious next question is, which one? Many IDEs are free in price, and you can install multiple IDEs if you wish to try more than one. Well, we will recommend a few of our favorite below. If you have some other IDE in mind, that's fine too. The concepts we show you in these tutorials should generally work for any decent modern IDE. However, various IDEs use different names, layouts, key mapping, etc. So you may have to do a bit of searching in your IDE to find the equivalent functionality. To a tip: to get the most value out of this site, we recommend installing an IDE that comes with a compiler that supports at least C++ 17. If you are restricted to using a compiler that only supports C++ 14 due to educational or business constraints, many of the lessons and examples will still work. However, if you encounter a lesson that uses capabilities from C++ 17 or newer, and you're using an older language compiler, you will have to skip it or translate it to your version, which may or may not be easy. You should not be using any compiler that does not support at least C++ 11, which is typically considered the modern minimum spec for C++. We recommend installing the newest version of a compiler. If you can't use the newest version, these are the absolute minimum compilers version with C++ 17 support: GCC, G++7, Clang++8, Visual Studio 17, 15.7. And now we have the different variants. Visual Studio for Windows now, for example. If you are developing on Windows 10 machine, which I do, then we strongly recommend downloading Visual Studio 2022 Community. Once you run the installer, you eventually come to a screen that asks you what workload you'd like to install. Choose desktop development with C++. If you do not do this, then then C++ capabilities will not be available. The default option selected on the right side of the screen should be fine, but please ensure that Windows 10 SDK for Windows 11 SDK is selected. Like here in this example, you just have the desktop development with C++, and you have to enable all these on the side. Those are most of the time by default all selected, and you can install them. And then if the disk space and or download size are a challenge, then Microsoft still offers Visual Studio Express 2017 for Windows Desktop, which you can find towards the bottom of the page. Microsoft is no longer supporting this product, and it doesn't have many of the newer C++ language capabilities. So we only suggest it for users who can not install Visual Studio Community. And I did install Visual Community, and that is also what we use that's also the IDE that we are using for our journey here. And then we have the example for code blocks, another IDE. Then also for Linux users and everything. Then we have macOS IDEs, and there are some more. When things go wrong, yes, other compilers platforms. Can I use a web-based compiler? Yes, for some things while your IDE is downloading, or if you're not sure you want to commit to installing one yet. You can continue this tutorial using a web-based compiler. We recommend one of the following: Tutorials Point, Wandbox, Godbolt. And web-based compilers are fine for dabbling and simple exercises. However, they are generally quite limited in functionality. Many won't allow you to create multiple files or effectively debug your programs. You will want to migrate to a full IDE when you can. And can I use a command line compiler? G++ on Linux. Yes, but we don't recommend it for beginners. You will need to find your own editor and look up how to use it elsewhere. Learning to use a command line debugger is not as easy as an integrated debugger, and will make debugging your programs more difficult. So as a beginner, just use an IDE that is capable of everything without console commands and everything, so you can just start coding and understand the language in general. Then to the last question of this section: can I use other code editors or IDEs such as Eclipse, Sublime or Notepad? Yes, but we don't recommend it for beginners. There are many great code editors and IDEs that can be configured to support a wide variety of languages and allow you to mix and match plugins to customize your experience however you like. However, many of these editors and IDEs require additional configuration to compile C++ programs, and there's a lot that can go wrong during that process. For beginners, we recommend something that works out of the box, so you can spend more time learning the code and less time trying to figure out why your code editor isn't working properly with your compiler or debugger. And then IDEs to avoid. You should avoid the following IDEs altogether because they don't support at least C++11, do not support C++ at all, or are no longer actively supported or maintained. Borland Turbo C++ does not support C++11, Visual Studio for Mac does not support C++, Dev C++ not actively supported. There is no good reason to use an outdated or unsupported compiler when lightweight. Free alternatives that support modern C++ exist. When things go wrong, aka when IDE stands for I don't even. IDE installations seem to cause their fair share of problems. Installation might fail outright, or installation might work but the IDE will have problems when you try to use it. Due to a configuration issue, if you encounter such issues, try uninstall the IDE if it installed in the first place, reboot your machine, disable your antivirus or anti-malware temporarily, and try to install it again. If you're still encountering issues at this point, you have two options. The easier option is try different IDE, different IDE. The other option is to fix the problem. Unfortunately, the cases of installation and configuration errors are varied and specific to the IDE software itself, and we're unable to effectively advise on how to resolve such issues. In this case, we recommend copying the error message or problem you are having into your favorite search engine, such as Google or DuckDuckGo, and trying to find a forum post elsewhere from some poor soul who has inevitably encountered the same issue. Often there will be suggestions on things you can try to remedy the issue. Moving on. Once your IDE is installed, which I have installed, which can be one of the hardest steps if things don't go as expected, or if you're temporarily proceeding with a web-based compiler, you are ready to write your first program. And now we go to the next program, 0.7, compiling your first program. Here, before we can write our first program, we need to learn how to create new programs within our integrated development environment, IDE. In this lesson, we'll cover how to do that, and you will also compile and execute your first program. Projects. To write a C++ program inside an IDE, we typically start by creating a new project. We will show you how to do this in a bit. A project is a container that holds all of your secure code files, images, data files, etc. that are needed to produce an executable or library, website, etc. that you can run or use. The project also saves various IDE compilers and linker settings, as well as remembering where you left off, so that when you reopen the project later, the state of the IDE can be restored wherever you left off. When you choose to compile your program, all of the CPP files in the project will get compiled and linked. Each project corresponds to one program. When you're ready to create a second program, you will either need to create a new project or overwrite the code in existing project. If you don't want to keep it, project files are generally IDE specific, so a project created for one IDE will need to be recreated in a different IDE. Best practice: create a new project for each new program you write. Console projects. When you create a new project, you will generally be asked what type of project you want to create. All of the projects that we will create in this tutorial will be console projects. A console project means that we are going to create programs that can be run from the Windows, Linux, or Mac console. Here's a screenshot of the Windows console. It will look like this here. By default, console applications have no graphical user interface, GUI. They print text to the console, read input from the keyboard, and are compiled into standalone executable files. This is perfect for learning C++ because it keeps the complexity to a minimum and ensures things work on a wide variety of systems. Don't worry if you are if you never used a console before or don't know how to access it. We'll compile and launch your programs through our IDE. which will invoke the console when necessary. Workspaces solutions. When you create a new project for your program, many IDE will automatically add your project to a workspace or a solution. The term varies by IDE. A workspace or solution is a container that can hold one or more related projects. For example, if we were writing a game and want to have a separate executable for single player and multiplayer, you would need to create two projects. It would make sense for both of these projects to be completely independent. After all, they are part of the same game. Most likely, each would be configured as a separate project within a single workspace solution. Although you can add multiple projects to a single solution, we generally recommend creating a newer workspace or solution for each program, especially while learning. It's simpler and there's less chance of something going wrong. Writing your first program. Traditionally, the first programs write in a new language is the infamous Hello World program, and we aren't going to deprive you of that experience. You will thank us later, maybe. Creating a project in Visual Studio 19 or newer. When you run Visual Studio 19 or newer, you should see a dialog that looks like this. And we will also make this. I have Visual Studio in my taskbar here, and I quickly start it. And as you can see, I have the same thing, just in dark mode, and we can choose that one what we want. And you then see a dialog that looks like this. First, before we see this dialog, we have to actually click on create new project, and we do that, and then we come to this window. And if you're already opened a prior project, you can access this dialog via file menu, new and project. Select Windows Desktop Wizard and click Next. If you don't see this, then you probably forgot to choose to install the desktop development with C++ workload. When you install Visual Studio, in that case, go back to lesson 0.6, installing an integrated development environment IDE, and reinstall your Visual Studio as indicated. Note, rather than doing a full reinstall, you can run the Visual Studio installer and modify your existing installation to add the C++ workload. Next, you see a dialog that looks like this. And now we do that as well. And we have to add Windows Desktop Wizard. And I quickly looked up what it is used for. It's basically for beginners. It has a detailed description what you have to do as a beginner, how Visual Studio works, and the default program in it is also Hello World. And when we click on it, we can name it here the specific name that we want, and we call it Hello World. And because I have this name already, I make a bottom line, because I know I haven't made my previous one like this, so the names are not equal. And here is my files folder. Here you can see where I store my folder, here in source and repos. And when we look in my folder, this is my video folder. Then on volume I have here a source, and then we go on repos and it will be here. There are some projects I'm currently on or have made already, and it will be in here when we press enter on this configuring file. And now when we have done this, replace the existing project with Hello World. It's recommended that you also check the place solutions and project in the same directory, as this reduces the number of subdirectories that get created with each project. Click Create to continue. Finally, you see one last dialog. Make sure the application type is set as console application exe and that the precompiled header option is unselected. Then click OK. Then we do that and we click create, and then precompiled header is unselected and it is exe, and then we can click OK. And then it's a little bit too big now, so I make it a bit smaller, and now we have an actual IDE to work with. Now I go back here, then we look what it says. You now created a project. Jump down to the Visual Studio Solution Explorer, select below to continue. Do section below to continue. And now we have a question. What are precompiled headers and why are we turning them off? In large projects, those with many code files, precompiled headers can improve compilation speed by avoiding some redundant compilation that tends to occur in larger projects. However, precompiled headers require extra work to use, and for small projects such as those we'll create in our tutorials, make little to no difference in compilation times. For this reason, we recommend turning precompiled headers off initially and only enabling them later if and when you find your compilation times suffering. And yeah, the precompiled headers only are useful if you have a lot of files, because they basically can better compile because they're pre-compiled and before the program compiles, and there is less code that the computer has to go through in this way. And then creating a project in Visual Studio 17 or older, we don't have that, so we can basically skip that part. And now this is all of that. Visual Studio Solution Explorer. Yes, we continue here. On the left or right side of the window, you should see a window titled Solution Explorer. And when we go in here, I have a little bit different setup here because I already programmed, but we can open it. If we search in the search bar Solution Explorer, we can find it and we can open it as well. And it should open. I don't know why it it's already open. It's on the left side. It's okay. And now we can go here, and then we have an output at the bottom. I had the output, but it was at the top. But if we would run our debugger, the output will pop up here, and we have it again. And I could put it at the bottom so it looks a little bit similar to the program that we see in our example. So we can see what our program does. Let's do it like this. And now Visual Studio has created a solution for you, solution Hello World. Within that, with the name in bold, is your new project Hello World. Within the project, Visual Studio has created a number of files for you, including Hello World CPP. Underneath the source file, 3 items. You may also see some other CPP or H header files, which you can ignore for now. In the text editor, you will see that Visual Studio has already opened Hello World CPP and created some code for you. Select and delete all of the code and type /copy the following into the IDE. So we can quickly do that. We basically delete all that. For now, we delete also the comments because we don't need them for the moment, because we want to follow our instruction here and we get not distracted by any other things. And now we paste that in here. I have not used the control buttons, but you could use them to control C and Control V, but for now this is good. And now we have our program, and now we can continue here. We paste it inside. To compile your program, either press F7. If this doesn't work, try Ctrl Shift B or go to Build Menu Solution. If all goes well, you should see the following appear in output window. And let's see if this works. We click F7. Yeah, for me it's the debugger is F5 and the output says all that, and we are getting the hello world exe run, and the console says hello world. And now we can go back, and we should find this somewhere. Build started, and then hello world CBP, and then hello world VCX project. And when we go back here, we could search for this. Let's try it again. Maybe we have some other output. No, but it's not exactly like we have it. Maybe when no, it does not say the exact same like in our example. It does not say build started, project, hello world, configuration, debug, Win32, hello world, CBP. It says something different. It just says loaded, and then from source repos hello world, and then it goes into x64 and it debugs it. This is the version that we use here to debug. So the library, and then it debugs it, and then we want to debug the hello world exe, and then we can run it, and those are all the linked files that we need, that the system knows where to access the code to run this, what we have here, the hello world command. And then it outputs us the hello world exe. And then we can go back. This means your compile was successful. Next question. I got an error C1010, fatal error C1010, unexpected end of file while looking for precompiled header. Did you forget to include SDAFX header or source? What now? You forgot to turn off precompiled headers when you created your project. Recreate your project as per the instructions above and make sure to disable precompiled headers. That's just the cross that you had to disable, or when it's not disabled already. And to run your compiled program, press Ctrl 5 or go to the debug menu and choose Start Window Debugging. You will see the following. Okay, here either press 7 to compile a program. This doesn't work. Try maybe I just try quickly something. If I click F7, does it something? No, it remains the same. And what was the other command? Ctrl Shift B. Ctrl Shift B. Let's see here. This works. Now you can see what the other one meant. Build started. Build 0 succeeded. 0 fails. 1 up to date. 0 skipped. Build started at this time. Maybe I have to start at the top. Let's try it. No, but the build started and it could be run, and it sadly is not. It does not say that it is the hello world exe that has started. It just says it started, and it says how long it took, 0.049 seconds to run the hello world. And that's useful. I didn't know that before, so it's already a benefit to relearn everything before I continue into the hard harder stuff in the language. And now we can continue. To run our compiled program, press Ctrl F5 to go debug menu and choose start without debugging. You will see the following. To run your compiled program, press Ctrl F5 or go to debug menu and choose start without debugging. And here, debug menu, and that was without debugging. And press any key to close this window. Okay. Or here, debug menu, and here you can see Windows debugger. No, it's basically this little button here on the side, start without debugging, if you want to do that. Or Control, what was it? Control F5. Let's see what it does. Control F5. Yeah, this is also running without debugging. And if we just click F5, it is with debugging, it's not just running. Yeah, that's perfect. Good to know. And now we can continue. That is the result of your program. Congratulations, you've compiled and run your first program. Related content: when you run a program directly from Visual Studio, you may see an additional line of output that looks something like this. See user Alex source repos project 6 debug project 6 process exited with code 0. And yeah, this is normal. Visual Studio is providing some additional information about whether your program exited normally or abnormally. We discussed this further in lesson 2.2, function return values, value returning functions. And we can also look at that when we run our program in Visual Studios. This time we run it without debugging, and then you can see this text exactly like he said. And then we can also run it with debugging. We have the exact same again, but another line as well to automatically close the console when debugging stops. Enable tools options debugging, close the console. This is just an information, but the other one is the one that always will be displayed. Yeah, that's good. And let's go back to the website. Create a project in code blocks. That's not what we are using. If you use code blocks, you can use this approach, but for us, we continue. And for Linux user, create a project in Visual Studio Code. We don't do that as well. If you're using G++ on the command line, this is not for us, because our IDE we don't use that. This is for IDEs that have a console by itself, that you have to say what they have to, when they have to do something. If compiling fails, that's the next one. It's okay, take a deep breath, we can probably fix it. First, look at the error message that the compiler gave you. Most often it will contain a line number indicating which line was in error. Examine both that line and the lines around it and make sure there are no typos or misspelling. Also make sure you're not including line numbers in your code. Your editor should be providing those. Second, look at the Q&A in lesson 0.8. A few common C++ problems as your issue may be covered there. Third, read the comments below the lesson containing the example you're compiling. Someone may have encountered the same issue and provided a solution. Finally, if all of the above fails, try searching for your error message on your favorite search engine. It's likely someone else has encountered this issue before and figured it out how to fix it. If your program runs but the console window flashes and closes immediately. When a console program is run, the console window will open and any output from the program will be written into the console window. When the program is finished running, most modern IDEs will keep the console open like we had in our example, until you press a key. So you can inspect the results of the program. Before continuing, however, some older IDEs will automatically close the console window when the program finishes running. This is generally not what you want. If your IDE closes the console window automatically, the following two steps can be used to ensure the console pauses at the end of the program. First, add or ensure the following lines are near the top of your program. So include is at the top. Second, add the following code at the end of the main function just before the return statement. That means if you have that, you have to include this limits, because the library that you're using is the limits library. I use now the Ctrl+C command to paste it inside. For this you would have to copy that in here, and for the other ones you have to copy that if the console closes. Just do that if the console closes, and then you have to enter or to copy that and enter this before the return to 0 and add this in here, and you can make a space here that it has clear space. And now we can run it and look what happens. Now we only have the hello world, so it does not close. And then we have the other one, but we don't use it. Maybe it looks different because our window does not automatically close, so it does not say everything. Because we have done this now, we have only hello world without the output now, because we have it in our program later. And when we do that, we have to press enter 2 times, because normally we have to enter it, or we can just type some letter, and then we can get to here, and then all the normal stuff will be displayed, and then we can enter another key and then it closes. But for us, we don't need that, and we can delete that again, because otherwise it would cause some confusions every time we run our debugger, or it does cause some longer times to run it, because we have to click so many buttons before it closes again. And now this will cause your program to wait for the user to press enter before continuing. You may have to press enter twice, which will give you time to examine your program's output before your IDE closed the console window. Yes, that's what we noticed. We had to enter 2 times and then again after that. Other solutions, such as commonly suggested system pause, that the whole system just pauses at this point, and when you click something it continues. Solution may only work on certain operating systems and should be avoided. So yeah, it is an example here, but don't use it. If the console window doesn't open at all and your program doesn't appear to be running, your antivirus or anti-vermel may also be blocking execution of the program. If that is the case, try temporarily disabling your scanners and see if the problem resolves, or exclude the project directory from your scans. A tip: if you are using antivirus or anti-malware, consider excluding your project directory from the scans, as compiling and debugging may cause false positives. Yeah, and now, what is the difference between the compile build, rebuild, build, clean and run start option in my IDE? In lesson 0.5, Introduction to the Compiler, Linker and Libraries, we showed that to produce an executable that can be run on each code file in the program is compiled into an object file, and then the object files are linked into an executable. When a code file is compiled, your IDE may cache the resulting object file. That way, if the program is compiled again in the future, any code file that hasn't been modified doesn't need to be recompiled. The cached object file from the last time can be reused. This can speed up compilation time significantly at the cost of a little bit of disk space. With that in mind, there's what each of the options typically does. The build compiles all modified code files in a project or workspace solution and then links the object files into an executable. If no code files have been modified since the last build, this option does nothing. Clean removes all cached objects and executables, so the next time the project is built, all files will be recompiled and a new executable produced. Those two mean the build is when you have run a code. The code here, for example, when I have we have run this code here and it's loaded. And when we would, for example, we save this example, close it, and then we go again in our folder. We are now in source repos with our folder. We click on it and open it. You have to open it on here. You can basically click on it and then it opens our console, and now when you can see, this is the clean build. When we run it now, it needs some time to run it and then it opens. And if we run it now again, it's a build file, not a clean file anymore, and it runs directly. And this is the difference. And then rebuild does a clean followed by a build. Have the modified files like stuff. Yeah, does a clean followed by a build. First it runs the program and then it runs it again, but quick, and then it runs. This is the rebuild. How to execute that? Yeah, that's basically like if we do it manually, we start a program new, start it, and then start it directly again. That's basically a rebuild. Then we have made this compile. Recompiles a single code file regardless of whether it has been cached previously. This option does not invoke the linker or produce an executable. I don't know how to do this yet. You can, like it says, you can just compile a section of your code, and here run start executes the executable from a prior build. Some IDEs, Visual Studio, will invoke a build before doing a run to ensure you are running the latest version of your code. Otherwise, code blocks will just execute the prior executable. Here are somewhere also start and stop option. If you start a debugger, if your code has something to stop at, it will stop. You can quickly see that there is an option that pops up a little bit red here, that you can enter something. I can quickly, you may don't know this, but this is a command that you can enter something, std sin, and then you can make this and then enter something. Let's make a variable x, and we just added a value to it. Let's say an integer x, and that's already enough. And then we can start a program, and then you can see it stops because we have to write something in. This is basically here it orders us to write the value for x. For example, we say because we have an integer, we have to make a number, and we take 3, and then the program would execute. And we delete that again so it does not confuse. It was just to show that the program can stop and start, and when you have a longer program, you get used to something like that, because it will soon stop because you have to do something before it does more. And then, although we talk informally about compiling our programs, to actually compile our programs, we will typically choose the build or run option in our IDE to do so. Conclusion. Congrats, you made it through the hardest part of this tutorial, installing the IDE and compiling your first program. Don't worry, if you don't understand what the different lines in Hello World program do, we'll examine and explain each line in detail at the start of the next chapter. So now we have finished chapter 0.7, and I think this is good for now, for today. And now we have a little more than half of the files that we have to do for the introduction, and we will see us tomorrow. I hope you enjoyed it or learned something watching it, and with that I say bye.